In this lesson, I'm going to cover Amazon EC2 Auto Scaling. Auto scaling is a really important service for maintaining the availability and automatic scaling of our EC2 instances. What it does is it will automatically launch or terminate instances based on whether the instance needs to be replaced or potentially you need to increase or decrease the capacity of your cluster. So you get to maintain the availability of your application and then scale it in response to certain things like changes in demand. It works with many different services. So we have EC2, it's actually launching and terminating EC2 instances. The Elastic Container Service, where it can be used to launch or terminate the nodes on which the actual containers run, and the same for the Elastic Kubernetes service as well. It integrates with quite a few different AWS services. A few of the important ones are, firstly, CloudWatch for monitoring and scaling. Your instances are constantly sending information to CloudWatch, and that can be information such as metrics on the CPU utilization. That information can be utilized by autoscaling to determine whether it needs to scale the cluster out or in, so adding more nodes or terminating nodes. We've got elastic load balancing for distribution of connections. If you're automatically scaling your instances, so autoscaling is adding instances to the deployment, then you want to make sure that the load balancer knows about that so that it can send incoming connections. So there's an integration there between the ASG, the autoscaling group, and the load balancer. And EC2 spot instances for cost optimization. Amazon VPC, of course, because we want the EC2 autoscaling group to deploy the instances within a VPC and across availability zones. So let's have a look at what it looks like in a nice diagram here. So here we have two availability zones, each with a subnet. Doesn't matter whether it's public or private, this one's public. And we create an auto-scaling group. And then we can define the number of instances we want to be running in that auto-scaling group. So here we might have defined that 4 is an acceptable number. That's how many we want to run at a steady state. Now there's two different scenarios I'm going to show you here. One is automatic scaling. So what's happening all the time is the instances are sending through information to CloudWatch, depending on the type of monitoring, either basic or detailed. That's either every 5 minutes or 1 minute. So they're sending metrics to CloudWatch, things like the CPU utilization. Now, if the metric reports that the nodes have in aggregate exceeded 80% utilization of their CPUs, CloudWatch can notify autoscaling to actually add a new node. So it's going to launch a new instance into that auto-scaling group. And this is all happening within CloudWatch using CloudWatch alarms. Alarms get created with certain thresholds for CPU utilization, and once those are breached, either instances need to be launched or they need to be terminated to bring the cluster back down to a number that's appropriate to the amount of demand at that point in time. So we want to cost optimize as much as we can. Now the second scenario is maintaining availability. Of course, instances can fail for some reason. Here the status checks have failed on one of these instances. So again, EC2 autoscaling is able to launch a replacement because that node failed. So those are the fundamentals of autoscaling. It's maintaining availability and scaling based on demand. So scaling out when we need more instances and scaling back in again by terminating instances when we no longer need them. And of course, it's going to talk to the load balancer to make sure the load balancer knows where to send incoming connections. With autoscaling, the scaling is horizontal. We're scaling out. So we're adding instances or we're terminating instances. So it's providing both elasticity and scalability. Elasticity is the scaling out. But then elastic means that it's able to scale back in again as well. So we're not just adding capacity, we're removing it when we no longer need it. Autoscaling will respond to EC2 status checks as well as CloudWatch metrics. And it can scale based on demand, so the performance, or we can do it on a schedule instead. So we can say, well, we know that we're going to need more capacity at a certain point in time, maybe 9 a.m. on a Monday morning when people are starting to utilize the application more. So we can scale on a schedule ahead of that point in time to make sure we've got the capacity if we want to. And it's scaling policies that we create which define how the auto-scaling group will change to demand based on those metrics or based on schedules. So let's have a look at the config. We have something called a launch template. This specifies the EC2 instance configuration. Few of the things that it includes, which are perhaps the most important to point out, is firstly the AMI, so the Amazon Machine Image. What's the operating system and configuration of the software within that operating system that we want to use for our instances. So of course we can create whatever operating system AMI we want with our application pre-configured if we want to, and then auto scaling is just going to launch many instances that are exactly the same. We choose the instance type, EBS volumes, things like instance profiles for IAM if we need to supply permissions to the instances, and so on. There's also something called a launch config. These are still available. They're older. They've been replaced really by launch templates, which have more options. So generally, we're going to be using launch templates. Now, in both cases, whichever one you use, we then get to configure things like the purchase options, on-demand versus spot for our auto-scaling group. We get to configure the VPC we want to deploy our instances into and which subnets across which availability zones. We can optionally attach a load balancer as we're deploying our ASG or at a later time as well. And you can configure health checks for both EC2 and elastic load balancing. And you get to configure the group size and the scaling policies. You can either statically define how many instances you always want to have running, or you can use the scaling policy then to either adjust dynamically or on a schedule. A few more key facts. So health checks, these are really important. We've got the EC2 health checks that the auto scaling group makes. That's essentially an integration into the EC2 status checks. So it's looking at what's coming through from the EC2 status checks. Is the system okay, or is it impaired in some way? We've then got the ELB health checks. These are used in addition to the EC2 status checks. And this just means that we're also able to receive information in the auto scaling group about what the load balancer is seeing happening. So the load balancer is also doing its health checks to the instances. If they fail, it's going to report that information back to auto scaling so it knows that it should terminate and restart that instance. We've got something called a health check grace period. This is how long to wait before checking the health of an instance. So we don't want the health check to start too quickly. If, for example, we're running some kind of bootstrap scripts or we're installing some applications and maybe the application's not quite ready yet. So we can give a little bit of a grace period to allow the system to come up once it's been launched and become operational. So auto-scaling doesn't act on health checks until that period expires. So we have different types of auto-scaling. We've got manual, that just means you're going in and manually making changes to the ASG size, so the number of instances you want deployed in the auto-scaling group. Or we have dynamic, and that automatically scales based on demand. So now we're looking at those CloudWatch metrics. There's something called predictive as well, which uses machine learning to predict what it thinks is going to happen based on what it's seen in the past. And then lastly, you've got scheduled, where you're scaling based on a schedule that you define. So when you expect you're going to need more or less capacity.